So, hello everyone, my name is Khiem and I'm doing my PhD at DCU. And I'm here to share about one of my project, and it's about quantifying reading quality. And this is done through monitoring the eye movements. So here's the outline of today's talk. So we're gonna go through some overview of our eyes, and then how we capture eye movements. And I'll talk about my reading experiment and how we extract the eye movements features and how we conduct the reading analysis, and then some key takeaway. So our eyes in brief. What you can see on the screen is a slide of our eyeballs, and it has many layers. So from the top left, we have the cornea, which is a transparent lens that covers our eyes, and it basically protects our eyes from foreign objects. And also it will help in reflecting the light coming to our eyes. And then in the cornea there's an iris. So most people, eyes colors is determined by the color of the iris. And in the iris there's a pupil. The pupil is basically responsible for adjusting how many lights come into our eyes. So if we are in a very bright environment, the pupil will shrink. So it will reduce the number of lights coming to our eyes so that it can protect our brain cell inside the eyes. And when we are in a dark environment, the pupil will dilate and become bigger so that we can absorb more light and we can see in the dark. So that's the pupil, and then after the pupil we have the lens. It's another layer that helps to reflect the light rays and help us to see the objects. So in the eyeballs, there's a retina, and on the retina there are basically the electrical cell. And so when the lights come to our eyes, it got reflected by the cornea, which is here, and then the lens, and then it ends up with an upside down image on the retina. And then the image is converted into electrical signal by the nerve cells on the retina, and then it will be sent to our brain through the optic nerves. So that's basically how our eye works. And so it's very important to point out that there's a small area called fovea on our retina, and that is where the visual acuity is the clearest, so we can see things very clearly when the image is light into the fovea. So what that says is what does that mean? It means that we can only see things very clearly when we put the objects into the focus point. So for example, we have two fingers here, you can only see one of the two fingers very clearly. So that's basically the structure of the eyes. And then how to capture eye movements. There are many techniques to capture eye movements. We can capture eye movements based on electrical signals like EOG, where people put electrodes onto the skin and then measure the electrical difference when the eye moves. The other way is remote, like having an eye tracker like this and then put in front of our eyes. And what the eye tracker does is that it will shine infrared light. The infrared light will record a reflection on our cornea. So there's a small point on our eyes which will reflect the infrared light, and then based on the difference between the pupil and the reflection, the eye tracker can calculate where we are looking at. So here's an image of myself in front of the eye trackers. So this is how the eye tracker sees my eyes. The circle thing is a pupil, and then the small dot here is a reflection caused by the infrared light. And then based on the corneal reflections and the pupil, we can determine where the pupil is looking at. This is like looking left and right. If the pupil is on top of the corneal reflections, it means that they are looking up and down. And so that's how I capture the eye movements, and here's the experiment. So we think of why not conduct an experiment about readings, and then we can have people come into the lab, do some readings, capture the eye movements, and then do some analysis on top of that. So this is how it's done. So we have the person sitting on a phone computer, we have eye trackers, and then the data captured and sent to the recording machines. But the person will basically sit there doing some reading tasks. So to make the tasks more clear, we have divided into multiple reading conditions. So we have reading, scanning, skimming, and proofreading. So prior they read the text, we will ask, okay, you will need to read this text, or you will need to scan the text, or you need to skim the text. So after they've done the task, they will evaluate their understanding of the text from 1 to 5. And then there will be 3 follow-up multiple choice questions to actually evaluate how much they understand the text. So here's a visualization of a skimming task, and you can see. So basically, the eye tracker will give us back the X and Y, which is the position where we are looking at the screen. So when we visualize the data, it's how it looks like. So the person is just reading from left to right in a very high speed because it's a reading skimming task. So the question is that, okay, we have the data points like the X and Y, the positions. How can we actually make some meaningful features out of that? So here's how we constructed the arguments features. But before going to that, I'll come back to remind you about the fovea. Yeah, it's a small point in the retina where the information is cleared. So when we are doing our reading, we have to move our eyes so that the words come into the foveas, and that's when we can actually read the words. So for example, the sentence like the brown fox jump over the lazy dog. This is how we actually see the sentence if we are looking at the word fox. So the word fox is very clear, and the surrounding areas become blurry. So in order to actually comprehend the sentence, we have to like look from left to right, but we have to move our eyes. So here's another visualization of the eye tracking data, but it's broken down into vertical movements and horizontal movements. And the blue lines here is a vertical movement. So you can see that it's going up and down and up and down. So it means that the person is reading from left to right, and then from left to right, and then going to the next line. So that's why the signal drops back to the 0, and then it's going up again, which means that they are reading from left to right again. So here you can basically tell, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. They are reading 11 lines. Then the text contains 11 lines. So based on that, we can form some actually meaningful features. So here's a small piece of the data, and there's a fixation second and things. Fixations are where is the event where our eyes remain kind of still. And in research, the average fixation duration is around 300 to 500 milliseconds, but it's going to be different from person to person. So that's just a reference number. So basically, fixation is where our eye stops and process the word that is in the fovea. And so whatever the flat line here is a fixation, and then the movement from one fixation to another fixation is called saccade, and it's gonna be quick. So whatever lines like that are the saccades, and then blinks are where we close our eye, and then all the data is gone. So that's why the lines is back to the 0, which means no data. So based on those fixations, we have the fixation X and Y, which is the position of the fixation. We can calculate how long is the fixation. So that's going to be the durations. How many fixations we make on the text. And then the same thing for saccade, but we also have the direction of the movement. So we are moving from left to right, or we are moving backwards, we are moving up or down. And then what is the magnitude and duration as well. And based on that, we can calculate the velocity, how quick we read the text, and then what is the distance between two fixations. So a very proficient reader can make a very large jump from word to word because they comprehend quickly, they can understand the text. And compared to a slow reader, they have to read words by words, so the distance will be short. and the velocity is low. So based on the data set, this is how I got from this is a comprehension score across different reading conditions. So 3 is the highest and 0 is like the lowest comprehensions. So for the skimming task and reading and skimming task, the comprehension level is actually higher than the scanning and proofreading. So scanning, they're just scanning through the text to look for a word, and compared to proofreading, they're just spotting errors in the text, so they don't really focus on comprehending the text. That's why the score is low. And so looking at the answer attempts from participant also tells the same patterns. So the participant attempts to answer a lot when they're doing reading and skimming tasks compared to scanning, because they don't really have information to answer to the questions. So I'm gonna skip through some the technical part that underline and show some results. So we are able to build a classifier to classify the 4 reading activities: reading, scanning, skimming, proofreading, and with it accuracy of 75.3%, and also estimating the reading comprehension level. We got 0.56 and 0.79, which is the correlation with the real with the ground truth comprehension score. We noticed that when we're using the comprehension score, which is calculated by the participant answer to the questions, actually lower than when we are using the subjective judgment, when people are giving their own judgment of their understanding from 1 to 5. And this is kind of true because the number of questions we use is only 3, so it does not really reflect the entire text and the entire comprehension of the person. And so somewhat the subjective judgment is more close to determine those things. And some findings on top of that is that the features when we use here's what we see here is the feature contribution on the machine learning model we built. And so the classification of the reading conditions actually contribute a lot to the model decisions. It means that the reading strategy or reading condition actually contribute a lot in determining the comprehension levels. And the third and fourth features is related to the regression rate and the velocity. So regression rate is a rate when people reading forward and then suddenly jump back to read something. So a high regression rate means that a person go back and reread some words very often, and that actually indicates some trouble in understanding the text. They might not understanding some words, or they might lost context and then reread, and then they reread the sentence to actually pick up some context, and that correlates to a poor comprehensions. And the same thing can be observed for velocity, which I mentioned before, like a very proficient readers can read very fast compared to a slow reader. So the key takeaway is that the arguments can actually reduce the reading strategy being used, which is the classification score that we had earlier. It also gives a glimpse into someone's comprehension level. And we also found that the reading strategy impacts how well we comprehend the text. So quantifying reading quality can actually help us in facilitating daily information indexing. For example, we work on computer every day, so we see information very often. So one of the ways that we keep information is that we make notes. So, but it's not very efficient if we have to make notes for everything we see. And sometimes there's an information need that we need to go back to what we have seen before to actually pick up something. For example, when I was writing my papers, I need some supporting evidence and reference. I know that I have read that supporting ID somewhere in a list of in a tons of papers I have seen, but how can I efficiently find it? It's really hard. So having a technique to actually estimating reading quality, reading comprehensions, we can actually weight the content we have seen in daily life. So it's not just a bland text, it's a text with weighted information based on our understanding. So it's going to be very useful. And think of it like a live logging, but enhanced with eye movements. In live logging, like Carl said, it just capture images, but where we are looking at in an image, it's not captured. So it's just an image without internal information from ourselves. So for example, in the image, Carl might be looking at a person compared to a car. So how can we index those information? We will need an eye tracker for that. So it's going to be helpful in our daily life. So that's the end of my talk. Any questions?
My question.
Yes.
Well done, was very interesting. So is velocity correlated with the reading velocity?
Yeah.
Is it correlated with the
Comprehension.
lower comprehension score or
So the lower velocity is correlated to the higher comprehension score.
Comprehension score.
Yeah. So if you read very fast, you might miss information. Yeah.
So do you have a strategy then for how to read and remember?
Yeah. So you need words by word. It means that you have a very high cognitive load, and then you are trying to understand word by word.
Yeah, it was interesting to see that skimming leads to higher comprehension level than proofreading or scanning for a text.
Yeah.
So maybe like a good
So like
strategy would be to skim something first.
yes. So like proofreading, we're basically spotting errors in the text, and we don't really pay attention to actually reading the content, and that's why it leads to a lower comprehension score. Yeah.
I wonder why, like you said, like higher the regression rate,
Yeah.
the comprehension score was lower.
Yeah. Because when you stop and regress, it means that you have to reread the sentence, the words, and it causes two things. The first thing is that you miss the context when at the word that just regrets back, and the second thing is that you have to reread the word or the sentence, meaning that you have lost the previous context as well. So it stops you from having a fluent reading flow. Yeah.
I feel like maybe like I as a reader might have read like I probably have like a higher regression rate, and I would have thought like it's for me it seems like the person who's reading is putting in an effort, and I would have expected them to have like a decent, I mean not a lower comprehension score. So that's surprising for me.
It actually like it happens a lot when you read something new, like you are researching about a new topic, and it contains a lot of terminologies.
Yeah, the terms
Yeah, so that's when you have a lot of regressions. Yeah, but it's also indicate that you are having a trouble reading the new piece of text, and then you have to regress back. Compared to a person who is actually the domain expert, when they read through the same text, they read it very fast. They don't do regressions. Yeah. So it's different level of comprehension.